Global steel output today is about 2 billion tons per year, which is a tenfold increase just within the last 70 years. So demand is massive and it keeps on growing.
If world steel were a country, it would be the third largest contributor to CO2. Number one is China, number two is US, number three would be Republic of Steel. So this is a major task if you're talking about massive decarbonization. If you don't steel in your plants, then you're missing a big piece of it.
Not all of that output is new steel. About 30% comes from recycling scrap metal, but the remaining 70% come from raw materials. And that's really the classic image that we have of steelmaking. It relies on huge blast furnaces that heat up the iron ore, limestone, and coke, which is really just a refined version of coal. But it's the blast furnaces that emit large amounts of carbon dioxide. And in fact, the steel sector is the largest industrial consumer of coal. So that's the dilemma that we're facing. On the one hand, we have steel, which is essential for infrastructure, for transportation. But at the same time, we cannot accept the carbon emissions that come with producing steel. And that's where Boston Metal comes into play.
It's called molten oxide electrolysis. And this is a case where we take the iron ore and we dissolve it in a high temperature solvent. By the action of electric current, we convert the iron oxide into liquid iron, and oxygen gas is the byproduct. So we replace CO2 emissions with something that's actually a second product. And this has been demonstrated at MIT, and Boston Metal is on the journey to build an industrial-sized reactor to be able to produce steel at the tonnages that are required.
That's going to be the long term. All of those heavy industry, how do you replace them with the newer technology that's cleaner? That's going to be a process that will take the next decades. It's going to be gradual, but it's going to come around.